Hey guys, welcome to Learn Today IGCSE. This video is a tutorial on chemistry, paper 6, variant 6-2 from October-November 2023 examinations. Question 1. Some seashells contain a mixture of the insoluble compounds calcium carbonate and silicon oxide only. Calcium carbonate reacts with dilute hydrochloric acid to form the soluble salt calcium chloride. Silicon oxide does not react with or dissolve in dilute hydrochloric acid. So I'll rewrite the reaction in a chemical equation form. Calcium carbonate reacts with hydrochloric acid and it forms calcium chloride, which is the soluble salt. Any reaction with carbonate will form carbon dioxide and water as its product. So the calcium carbonate here is an insoluble compound which is coming from a seashell. So the seashell contains calcium carbonate and it contains silicon oxide. They say that the silicon oxide will not react with hydrochloric acid but calcium carbonate will. Okay, a student wants to find the percentage of silicon oxide in a seashell. The first 4 steps of the method the student uses are as shown. So step 1, the student grinds the seashell to form a powder. Step 2, the student finds the mass of the powdered seashell. And then step 3, the student adds the powdered seashell to an excess of dilute hydrochloric acid and heats while stirring with a glass rod as shown in figure 1.1. So over here is the powdered seashell, which is reacted in excess of dilute hydrochloric acid. Step 4, the student filters the mixture as shown in figure 1.2. Since we are using excess hydrochloric acid, it means that we want all the calcium carbonate to fully react. So the residue here can be the leftover of unreacted hydrochloric acid or some calcium chloride or even a little bit of water. Question A. Name the apparatus used to grind the seashell to form powder in step 1. So this apparatus is something that you should know beforehand. You're going to use a pestle and a mortar to crush it. Next, question B. Explain why it is important that dilute hydrochloric acid is in excess in step 3. If HCl is added in excess, it's because we want all the reactants of calcium carbonate to react completely. This is quite a famous question that will always be asked in also paper 4 and paper 6. Part C. Name the items of apparatus labeled A and B in figure 1.2. So this is A and this is B. A is a tool that is filtering this solution and B is a container that is collecting the filtered solution. You can take a screenshot of this and please memorize them before you take your examinations. So A here is a filter funnel and B is a conical flask. Question D. The residue obtained in step 4 is not pure. Part 1. Identify one substance other than water that is in the residue and prevents it from being pure. So as mentioned previously, other than water, it could be containing calcium chloride or the excess hydrochloric acid which was unreacted. Question part 2. The student washes the residue. Describe 2 additional steps that the student must now take to find the percentage of silicon oxide in the seashell. So to find what silicon oxide is left in the seashell after washing it, we have to dry it to remove any water that is containing in the seashell. And after removing the water, we can determine the mass and calculate the percentage of silicon oxide. Question 2. The student investigates the temperature change when aqueous sodium hydroxide, this, neutralizes dilute hydrochloric acid, and the equation for the reaction is shown below, over here. The student does 6 experiments. Experiment 1. Firstly, the student fills a burette with dilute hydrochloric acid. So this is the burette. And then the student runs some of the dilute hydrochloric acid out of the burette. So it was run out so that the level of the dilute hydrochloric acid is on the burette scale. Next, fill a second burette with aqueous sodium hydroxide. So the first one was for hydrochloric acid and then a second burette was filled for sodium hydroxide. Same thing, run some of the aqueous sodium hydroxide out of the burette so that the level of the aqueous sodium hydroxide is on the burette scale. Next, run 1 centimeter cube of dilute hydrochloric acid from the burette into a boiling tube. So you have a boiling tube and it was filled with 1 centimeter cube of hydrochloric acid. And then run 9 centimeter cube of aqueous sodium hydroxide from the second burette into the same boiling tube. So now you have 9 centimeter cube of sodium hydroxide. So a total of 10 centimeter cube of solution. Okay, Stir the mixture with a thermometer and measure the highest temperature reached. Measure the pH of the mixture in the boiling tube and rinse out the boiling tube with distilled water. And for experiment 2, the same experiment repeated but with different amount of hydrochloric acid and a different amount of sodium hydroxide. And for experiment 3, it's the same. Different hydrochloric acid and different amount of sodium hydroxide. So the concentration of hydrochloric acid to aqueous sodium hydroxide was changed from experiment 2 to experiment 6. What remains the same, the total amount of the acid and sodium hydroxide is the same, which is 10 centimeters cubed. Next, part A, use the description of the experiments and the thermometer diagrams to complete table 2.1. So we know that hydrochloric acid added up with sodium hydroxide will give us 10 centimeter cubed. For the first experiment, the volume of aqueous sodium hydroxide was 9 cm cubed, and the temperature here is 26.0 degrees Celsius. Since the existing value in the table comes with 1 decimal place, I'll do the same for also the temperature. Now we'll just repeat the same step until experiment 6. These 4 marks can be easily obtained, so please do not make any mistakes in reading your scales or filling up the volumes from your experiment instruction. Next, question B. Add a suitable scale to the y-axis in figure 2.1. So here is your y-axis, which is the highest temperature reached in degrees Celsius. Your scale should extend by 2 degrees Celsius above your highest temperature in table 2.1. The highest temperature in table 2.1 was 30.5. So the scale should be an extra of 2 degrees Celsius. So minimum here must be 32.5 degrees Celsius. Plot your results from experiment 1 to 6 on the grid. Draw 2 straight lines through your points. One is through the first 3 points and the other is through the last 3 points. Extend your straight lines so that they cross. Okay, we'll do this first by filling up the scale for y-axis. The range of your temperature is from the lowest 26 to the highest 30.5. We have 5 boxes. So I'm going to reduce my scale down to 24 degrees Celsius and then add on 2 degrees Celsius for each boxes. Let's see if we manage to reach until at least 32.5 degrees Celsius at our highest scale. So 24, 26, 28, 30, 32 and 34. 34 here is our highest scale and we did extend indeed more than 2 degrees Celsius. Now that you are done with the scale, you can go ahead and plot your points. And you will get something like this. So the instruction says that draw straight lines through the first 3 points like this and one through the last 3 points, which are these 3 points. And then extend your straight lines so that they cross, and we have done that. Question C. The point on the graph where the 2 straight lines cross is where all the aqueous sodium hydroxide reacts with all of the dilute hydrochloric acid to form a neutral solution. Part 1. Use your graph in figure 2.1 to deduce the volume of HCl and the volume of aqueous sodium hydroxide that reacted together to produce a neutral solution. And then show your working on figure 2.1. So let's see where do they cross. So they crossed at this point. I got at a volume of 4.5 centimeter cubed. So we have learned that the total solution is 10 centimeter cube, meaning that minus 4.45 centimeter cube of HCl will give us the volume of sodium hydroxide. Next, predict the pH of the solution in the boiling tube when the volumes in part C1 are mixed together. Okay, they have mentioned that it will form a neutral solution. A neutral solution has a pH of 7. Next, part 3. Deduce which solution, dilute hydrochloric acid or aqueous sodium hydroxide, is the most concentrated. Use your answer in C part 1 to explain why. So we need to find out whether HCl or sodium hydroxide is more concentrated. When both reacted together, it forms a neutral solution of pH 7. And as we can see that HCl requires a smaller amount compared with sodium hydroxide to reach a neutral solution, meaning that HCl is stronger or more concentrated compared to NaOH. So the solution is hydrochloric acid, and as for the explanation, you can mention that the volume is lesser or smaller compared to sodium hydroxide in order to be neutral. Next, question D. State how the pH and the temperature recorded in each experiment would differ, if at all, if a polystyrene cup is used in place of the boiling tube. A pH of a solution is only dependent on the concentration, so there will be no differences for the pH. However, for temperature, using a polystyrene cup will indeed change the temperature because, comparing to a boiling tube, it will prevent heat loss towards the surrounding. So as for the temperature, yes, there will be a difference, and the explanation is that you can say is because polystyrene is a better insulator compared to a boiling tube, preventing heat loss to the surrounding. Next, question E. The volumes of the solution used in these experiments were measured using a burette. Explain why a volumetric pipette could not be used instead of a burette in this experiment. The range of volume for this experiment was between 0 to 10 centimeters cubed. Burettes are the most accurate way of measuring a variable volume of liquid between 0 to 10 centimeters cubed. Hence, we use burette in this experiment, whereas a pipette is only available in sizes of 10 centimeter cube and 25 centimeter cube. So this is the reason why a pipette was not used. Question part 3. A student tests two substances, solid K and solid L. Question 3 of Chemistry Paper 6 is always regarding tests on anions, cations, gases, and flames. So I hope you have memorized all the tests and their results. Test on solid K. The student dissolves solid K in water to form solution K. The student divides solution K into 4 portions. So the solution K was divided into 4 portions like this. Test 1. To the first portion of solution K, add a few drops of aqueous ammonia. To answer this, I'm going to open the anion test and the cation test tables next to your page so that it's easier for us to refer. Alright, when added a few drops of ammonia, a white precipitate is observed. So this is a test for cations. When added a few drops of aqueous ammonia, white precipitate is observed for aluminium 3+ and also zinc 2+. So this could be zinc 2+ or aluminium 3+. Next, to the second portion, a few drops of acidified aqueous potassium manganate is added and a pale purple solution is seen. Acidified potassium manganate is tested for the presence of sulfide. If there is presence of sulfide, the acidified potassium manganate will change color from purple to colorless. However, in the observation here, the pale purple solution remains unchanged, meaning that there is no sulfide present in this solution. Next, to the third portion, 1 centimeter cube of dilute nitric acid followed by a few drops of silver nitrate is added. This is a test for halides. So for chloride, bromide, and iodide, which is halogens of group 7, it will be tested with adding nitric acid and silver nitride. So a cream precipitate is observed here. If a cream precipitate is observed, it means that bromide ions is present in this solution. So this solution has Br-. And for the last portion, adding aqueous chlorine, and the solution becomes orange. Now again, this is a test for halogens. So we have a test of halogen displacement reaction over here, whereby when chlorine is added to a solution that contains bromine, the chlorine will displace bromine to form bromine, which is orange in color. So here's another proof that this contains bromide. Okay, now that we have gotten all the information, we can answer the questions. Part 1. Identify two cations that test 1 shows could be in solid K. So in test 1, we've got zinc 2+ and aluminium 3+. Next, part 2. Describe an additional test that could be carried out on solution K to confirm which of the two cations you have identified in A1 is in solid K. Explain how the test will show which one of these two cations is in solid K. Cations are positively charged ions. So as you can see here, we don't know whether it is zinc or aluminium. So to check whether it is aluminium or zinc, what we can do is we can add excess ammonia. If it is insoluble, then it would be aluminium. If it is soluble in excess, then it would be zinc 2+. This is how we can differentiate or identify between these two. Next, part B, identify the anion in solid K. Anion is your negatively charged ion, and the anion here is bromide. Next is the test on solid L. Solid L is barium nitrate. So the cation is Ba2+ and NO3- is the anion. Question C. The student carries out a flame test on solid L. So this is your table for flame test. Make sure you have memorized them. Since this solid contains barium 2+, you will see your flame color light green. Next, the student dissolves the remaining solid L in water to form solution L. So meaning that now it will just form an aqueous solution and it will dissociate to form barium 2 plus and NO3 minus ions. Okay, the student divides the solution L into 3 portions. To the first portion of solution L, the student adds a piece of aluminium foil and 5 cm cube of aqueous sodium hydroxide and warms the mixture. The student tests for any gas produced. Once the solid dissolves in water, there will be nitrate ion. And for the test of nitrate ion, as mentioned in the question, we will be adding aluminium foil, sodium hydroxide and warming it carefully. And the gas produced would be ammonia. So any gas produced is yes, which is ammonia. However, for your observation, we cannot say that ammonia is produced because ammonia here is the product, is a gas which cannot be seen unless it has a certain color and can be identified, such as the chlorine gas, which is greenish yellow. So when tested ammonia gas, which is alkaline, it will change a damp litmus paper from red to blue. Remember, when asked for observations, your answer cannot be whatever product that you get. Your answers are either usually colorless bubbles, bubbles with color, or even the change of solution color. So please keep this in mind. Question E. To the second portion of solution L, the student adds 1 cm cube of dilute nitric acid and a few drops of aqueous silver nitrate. This here is a test for halides. You will see on your table that when added dilute nitric acid and silver nitride, it is all to test for halide, and in this solution there are no halide present, meaning that for your observation there will be no any changes seen. If you were asked why, then you can mention that this is because there are no halides present. And for the third portion of the solution L, the student adds 1 cm cube of dilute sulfuric acid. This here is a test for sulfates. When testing sulfate, we will add nitric acid, which contain nitrate ions, and solution L indeed contain nitrate ions. Since sulfate is placed above nitrate ion, it is more reactive than nitrate. So it will displace nitrate to form barium sulfate, which is a white precipitate. So white precipitate here would be your observation. Question 4. Planning an experiment. You are going to need lots of practice for this. Try as many questions as possible, and you can follow the technique that I'm about to use to plan this experiment. The solubility of solid sodium sulfate in water changes as the temperature of the water changes. Plan an experiment to find out how the solubility of sodium sulfate in water changes with temperature. You are provided with sodium sulfate, distilled water, and common laboratory apparatus. Firstly, identify the variables that is existing in your experiment. I like to use the acronym I don't care, IDC, to remember which variables I'm looking for. Your independent variable here is what is being changed in the experiment, and what is being changed is the temperature. And then you're going to look for your dependent variable, which is what is being measured. And what is being measured here is the solubility of sodium sulfate. And lastly, your constant variable. Your constant variable is what's going to keep the experiment fair, and it's extremely important. It can vary depending on how you conduct your experiment. So to ensure the test is fair, we're going to use the same amount of distilled water and the same amount of sodium sulfate. Now that you have identified your variable, we're going to ensure that we mention all these 3 variables in our experiment. Firstly, let's design the setup of this experiment. So we're going to fill up a beaker with a stated volume of distilled water. So I'm going to use 50 here. We're looking to investigate the solubility of sodium sulfate. This is what sodium sulfate looks like. Again, we're going to add a stated amount of sodium sulfate into the distilled water. So I'm going to use 10 grams of sodium sulfate. Now, after setting up the experiment, we are going to discuss about the dependent variable, which is the solubility of sodium sulfate. So what we are going to do to test the solubility or to measure the solubility of sodium sulfate is that we're going to stir the solution of sodium sulfate in the distilled water and filter out the residue form. The dissolved sodium sulfate will go into the beaker, and the undissolved sodium sulfate will be left in the residue here, which later on you can weigh and use this mass to test the solubility of sodium sulfate. If there is a lot of residue left behind, this means that the sodium sulfate did not dissolve completely in the water. Okay, We have talked about the constant variable over here. We are done with the dependent variable over here, and next we are going to talk about the independent variable which we are changing in this experiment. So next we are always going to discuss about repeating the experiment with a different independent variable, and the independent variable here is the temperature. And just to be safe, I like to state the temperature that is being used in the experiment. And lastly, you're going to write the conclusion or the hypothesis for this experiment, which is the relationship between the independent variable and the dependent variable. So the independent variable here is different temperature, and the dependent variable here is the solubility of sodium sulfate, which will be measured by the mass of the residue. We have learned in the topic of rate of reaction that higher temperature means higher rate of reaction. So with a higher temperature, the mass of the residue will be less because all the sodium sulfate will dissolve in the water. So here is your final answer. I have written this down in point form, and please don't follow how I have written. Make sure in your exams you write all of this in paragraph form, and you will be able to get a complete 6 marks. What you should keep in mind is that always state the volume, masses, temperature or distance that you are changing or even measuring in the experiment. Mention the apparatus that you will be using in the experiment, as you will not know where your marks are coming from. And lastly, use the same amount of your constant variable to make sure that this experiment is fair. Alright, that's all for this video guys. Thank you for watching. I hope it was worth your time. For the next video, I will be uploading Mathematics Paper 4 too. Please subscribe to my channel to prepare for your IGCSE examinations. Bye bye, take care.